Hello, this is E7A, Economic Equivalence and Factor Tables. I actually have made a separate video about the factor tables that go along with this particular problem. So make sure you look at E7B if you're not quite sure how to use the factor tables, or you may be able to figure that out for yourself. All right, so briefly, economic equivalence of two sums of money received at different points in time implies that a person is indifferent between the two sums of money. So for example, if I gave you $100 today and they said, oh, wait a minute, would you rather have $100 today, or I could give you $120 in exactly a year, and assuming that you trust me to actually pony up the money, and you said, well, I really don't mind, then we would say that you regarded those two sums of money, $100 today or $120 in 12 months, as being economically equivalent, which economists also call, we would say you're indifferent between the two sums of money. Another important thing about equivalence is that it's quite it's subjective. The rate at which people discount the future is going to vary, and it might vary over your lifetime. So when you're young and you have a lot of years ahead of you, you're likely to have a lower discount rate than when you're old and you don't have many more years left. You're going to heavily discount the future and try and live for today. And the other interesting thing about the subjective nature of people's internal sense of how to treat the future, how to discount the future, is that college students in general have lower discount rates or interest rates than the population that doesn't go to college, because in order to reap the rewards of college in terms of a potentially higher wage, you have to incur upfront costs. So people who have low discount rates for the future tend to be more likely to go to college. Okay, so we're going to start out with the simplest possible type of question. This is a single sum of money. So let's say we have $100 today and we're going to put it in a bank. P is $100 at an interest rate of 10%. for 10 years. So the interest period is a year, and N is 10 for the number of interest periods. And what we're interested in is finding the future value. And with cash flow diagrams, you can really see graphically what's going on. So you can see that we have $100 is a negative because it's money that we hand over to the bank. So that has a negative down arrow at time 0, which is the present. And then we have 10 years elapsed, so I could actually mark this out as each year and so on. So, you can imagine. So we've got 10 years going forward. So 0 stands for the present. I is the 10% interest rate, and we want to know what F is. So from your book, you will be able to find the relationship between F and P. F is equal to P multiplied by 1 plus I to the N. We call 1 plus I to the N the factor, and we're going to use factor tables to look that up. Another simple way to do that is to just use your calculator for these simple problems. So this question becomes F is equal to $100, our principal, multiplied by 1.1 to the power of 10. 1.1 to the power of 10, and I'll show you in the other video how to figure that out, is equal to 2.5937. So that means that we have solved our problem. If you had $100 today and you put it in a bank for 10 years at 10% interest rate, 10 years from now, you could withdraw $259.37. So we have used a present value, an interest rate, knowledge about what the interest period is, and the number of interest periods to calculate a future value. And that's something that you will find very useful going forward. But in the next video, I will talk about different ways to find that factor, 2.5937. So you may have stumbled across that in the D2L already, but if you haven't, then follow me to the next video.